Thanks all for sticking with us. We've had a jam-packed day full of outage war stories. We've heard about capacity management through service degradation, how we can learn from SLO violations, how to make configuration changes safer, minimizing the impact of production incidents, and we've learned about Meta's SEP process and culture. There's lots to discuss here. My name is Christian Monzon. I'm a technical program manager here at Meta within our Reliability Engineering Initiative. I've had the pleasure of helping coordinate this event today, and I also have the privilege of working very closely with a lot of the engineers that presented here today. We're going to close out this event with a live Q&A where we'll start off with some questions that I have for the presenters, and then we'll open it up to you, the audience, for any questions that you may have. And as a reminder, you can submit your questions using the Q&A toolbar at the bottom of the webinar. But before we jump into all of these questions, I want to warm us up with a little definition exercise. What I find fascinating when we approach reliability is that the concept of reliability is generally pretty well understood, right? But when you go and ask folks to define reliability, you get a pretty broad spectrum of definitions and perspectives. I think that's actually exemplified here today, where in your presentations, you all talked about different topics of reliability, but you approach it from very different perspectives. So I want to start us off by, let's do a quick name, and then I want 2 words that you would use to describe reliability. And Joe, I'll pick on you to start first.
All right, happy to. Hi, I'm Joe Gasperetti, and on the cuff, I'll say reliability is often invisible.
All right, I'll pass it off to Nick.
Hey, thanks, Christian. Hey, I'm Nick. When I think of reliability, I think highly impactful, which is not what everybody would think when they think about reliability work, but I do.
I'd agree. Avery, your 2 words.
Hi, everyone. I'm Avery Bercheck. I'd say reliability to me is no surprises.
Although sometimes we do get some of those surprises. Keshav, I'll pass to you.
Hey, I'm Keshav, and to me, reliability means moving methodically.
I like it. Yi.
To me, reliability is very important.
Can't argue there. Thote?
Hey, I'm Thote. For me, making things predictable, probably.
Awesome. And Kostya?
Hi, I'm Kostya. And for me, reliability means no calls in the middle of the night.
Yes, that's the ideal state. I'll give you my 2 words. I'll say nebulous yet understood. Okay, let's jump into some questions that I have for you all, and we'll start off with Keshav and Kostya. Your talk was about SLOs and how you can learn from SLOs through annotations. I think SLOs, SLIs are arguably a foundational layer to approaching reliability, right? What's that saying? You can't manage what you can't measure. And so we have SLOs. During your presentation, you were talking about the value of annotations. And I think, Kostya, you had in one of your slides a quote, "My SLOs are red. I have no idea why." I like that. But this is where annotations can provide useful insights and value. And you demonstrated that when you're feeding these annotations to produce long-term analysis, and which could eventually lead to insights. And showing value is good, but at some point, someone has to create those annotations. Can you talk a little bit about how you convince teams to add annotations?
Yeah, thanks for the question. Well, of course, we are not going to force anyone. We can't force people to annotate their stuff. But what we want to do is to actually show them the value. And in Slick Team, we are planning to introduce a SLO violations review process where teams would gather together every month or some custom period of time and talk about what was happening with their SLIs, if there were any SLO violations. And if they did their homework good, if they were annotating all their events in the past months, they will have everything already kind of pre-filled for them. They will see all the insights and all the statistics and all of that things. So it will make the life just easier for them, that they will not need to try to recall what was happening weeks ago. So yeah, just we hope that simplifying life for people would be a good motivation.
Yep, I'd agree. I think it's easy to convince someone to do something if it's easy, right? So, Keshav, you convinced Instagram annotations are important. When going through adding annotations, especially with some SLOs, we can see a lot of spikes and sort of variation blips that come up. I'd imagine that annotating each of those sort of spikes that you see might be tedious. How do you go about sort of showing value there or convincing the team that it's still important to do so, even if the spike was maybe caused by a dependency that is no longer relevant?
Yeah, it's a great question. As Kostya kind of mentioned during the talk itself, Instagram itself has been trying to take advantage of another tool called Dr. Patterson to kind of help turbocharge our annotation process. Especially for the small blips, annotations are incredibly important because these are often the ones that, at least for us, go undiagnosed the most frequently because, again, once it's resolved, there's a little bit less interest in trying to pursue and analyze what went on. But they can actually still make up, in some cases, a very significant portion of overall reliability events. So we understand that we need to reduce the human toll, and we're doing that through automation, but in general, these are the most valuable annotations that we generally find.
Makes sense. Okay, so I think reliability at the service level, you have SLOs and SLIs, annotations are valuable. Makes sense. If we zoom out a little bit, we can start talking about reliability at a massive scale, especially a scale like the one that Meta operates on, where you have billions of users making requests. So for that, I want to chat with Thote and Yi. Thote, in your presentation around service degradation at scale, you mentioned that we have 3 billion people that rely on our products daily. I think that's an incredible amount of users that we have, but service degradation is a solution that has slowly been evolving over the years, but really became impactful and important when the pandemic hit. How do you go about reducing the impact that these tests in production have on our users without losing signals that contribute to overall reliability?
Yeah, thank you. As we mentioned in our talk, service degradation is used as an emergency response tool. And reliability is very critical for these emergency response tools because they are going to be used when things are on fire. So at the same time, service degradation by nature is going to impact users. So we have these two contrasting factors that we need to balance while thinking about ensuring reliability. So our solution to this is running two kinds of tests, as we explained in the talk as well. So we have A/B tests. These are small-scale tests which we run on regular cadence. These are run on a small percentage of users, or on a shadow traffic, or asynthetic traffic, so that we reduce the impact on users. But we try to maximize on getting signals on the functionality and amount of savings that we get back from these tools. At the same time, because reliability is important, we need to run tests in production to have 100% confidence to use this tool in production. So we run another kind of tests, which are run on entire user base. We run it for very short time. We use this mechanism to validate that the signals that we got from A/B tests holds good even in the complete production environment. And also we try to figure out if there are any unknown factors that impacting the overall reliability of the tool. So by using these two tools, we try to balance the reliability aspect as well as the impact on users.
Makes sense. Continuing on the same topic of impact to users, I wonder why we don't just test in maybe a staging tier or by shadowing traffic as opposed to in the production environment. Maybe you can help me out with that.
Sure, that's a really good question. The short answer is we want to observe the user behavior changes in production environment. And that's not available in the shadow traffic tier. For example, we observed something really interesting that by disabling notifications, we observed an increased watch time of videos on Facebook.com and also less access to the marketplace. our assumption is that the users, they were less distracted from watching videos. So they basically stayed on the videos for a longer time. And at the same time, because they received less notifications, they were less redirected to marketplace. Things like these are the signals we want to observe from small scale tests. And in return, we are able to reduce the impact on the majority of the users if we enabled such degradation techniques globally.
Makes sense. Thote, you mentioned, really this is used for when we have to degrade services, but how often are we enabling these degradations in production to resolve any real outages or issues?
Yeah. So taking a step back, we use service degradation at multiple levels. So we used service degradation at global level when the entire site is down, where we enable service degradation for all services. Then we also use service degradation at individual service level, where there are issues pertaining to the specific service. And we also use it when one of the downstream dependent service is facing overload issue. Then you can use the upstream service to reduce the load on the downstream service. So as we also explained, we have used site level service degradation during one of our global outage. But outside of that, we see at least once per year usage on the rest of the service degradation tools. As I also mentioned before, this is something that we have started to mature these days. So I expect this to be used more frequently going forward as we establish more use cases.
Right. And there's also the evolution of this approach that you mentioned, unified site degradation, which, maybe in the next Reliability at Scale conference, we can learn a little bit more about. I want to switch gears a little bit, and let's talk about config changes. So it seems like config changes seem to be a usual suspect anytime we have an incident or an outage. But Avery, you've been doing a lot of work to make that process a lot safer. In your presentation, you talked about how we've evolved from the manual testing now to some of the automated solutions that we have. And you also showed an exponential curve of adoption of Auto Canary. I think you mentioned that a lot of that adoption happened organically. Can you talk a little bit about how that organic adoption happened and maybe what contributed to it? And how did you convince service owners to care about this work?
Yeah. These are good questions. So I'd say a lot of the adoption in the early days was organic. And looking back at it, I'd categorize it into two areas, proactive adoption and reactive adoption. As we've mentioned in a few talks, we have this SEV review process in which we could learn from past SEVs and take action to prevent them from happening again. And one of the things that was frequently brought up back then when there was a SEV triggered by a config issue was, well, should we enroll an Auto Canary? And can we gain that protection with Auto Canary to prevent this from happening again? So there were a few scenarios where folks onboarded due to reactive approaches, and also proactive approaches were pretty big. So we did we invested a bit in actually documenting what Auto Canary is, how it applies to your service or your workflow and whatnot, and showing folks how to use it. And we even taught this in some classes too, to spread awareness. So we marketed it out there a bit. And I'd say as a part of folks turning up new services or just looking to add more reliability to their services, they proactively onboarded to Auto Canary to get that protection.
Makes sense.
And go ahead.
Finish your thought there.
Okay. I was going to say, in terms of driving it and all that, because this was the organic approach, we drove a lot of work to actually evangelize this. But that was, I guess, the main action that we took there. After the organic approach, when we wanted to make it easier to onboard and actually proactively push for it ourselves, that's where we dove into a lot of the work that I talked about in our talk, especially with the most recent thing being that automation to automatically generate those enrollments. Right.
Makes sense. Again, that theme of making it simple for folks makes it easy to drive adoption. I want to switch gears again. Within the same talk, you were talking about the multiple comparisons problem with regards to Canary specs and how you managed to scale it using Canary Spec Doctor. One of the things that Canary Spec Doctor does is that it will skip a Canary Spec if it determines that it's unhealthy, right? If Canary Specs are skipped when they're unhealthy, what do you do to improve them? Or what's the process to sort of maintain them so that they're not just dead code?
Yeah. So we want to bring these specs back. So of course we skip them when we go unhealthy because we care about our developers and want them to be able to move fast. But we also care a lot about safety. So we want to run these specs and keep them healthy. So among other things, Spec Doctor advises on skipping and whatnot, but it also automatically reaches out to owners of the Canary specs when those specs go unhealthy to notify them like, hey, if your spec's unhealthy, here's some debugging resources that you can follow to see why it went unhealthy, areas that it could be improved so we can bring it back online again. And even beyond that, I guess to the point that you made of like making things simple, we're working on a solution to automatically suggest improvements to the quality of Canary specs and health checks. That way, one, we could catch these things before they go unhealthy in the first place, and two, make it even easier to fix them when they do go unhealthy.
I love it. Stepping back a little bit, just in terms of thinking about this theme of developer speed and safety, I'd imagine that you might have met some friction in terms of feeling like these additional safety layers were at odds with developer speed. Can you talk a little bit about how the team balanced that? And are the two really at odds, would you say?
Sure. So we want both. Again, we want developers to be able to move fast. That's a big company value. And we also want to keep this stuff safe. And so how do we balance those two? I'd say the main thing that we've done historically is keep an eye on individual indicators of each component of developer experience or safety. And based on what we observe for those components, we could allocate resources accordingly to projects that will improve the causes of components regressions or causes that we think will bump the component. And so that's usually how we go about it. Going forward, those projects, as you can imagine, can take some time to roll out. And we may want to rebalance things quickly due to changing external factors. And so that's where that thing I talked about in the talk comes into play, which is that system to gauge the risk of a config change and act on it. That way we can keep those things in balance. And in terms of if they're at odds with one another, they do trade with one another in some scenarios. Like, for example, in this talk, I talked about skipping those Canary specs. We could skip more specs at the potential cost of a bit of safety, maybe to get more speed, and vice versa. And while there are trade-offs, I'd say that the two also complement each other really well. So there's some scenarios where too much friction in the auto Canary experience can regress that workflow to a point that it impacts the auto Canary usage and thus like that safety add that we have with auto Canary. And also, I guess too little safety could result in a lot of people needing to do firefighting and go fix up the issues that are a result of those config changes impacting the developer experience as well. So improving each can have a nice impact on improving the other one too.
Yeah, I agree. You could say maybe move reliably to move fast, or slow down to move fast. I don't know. There's a slogan in there somewhere, but I agree. I think there's probably a little bit of a cultural shift there that goes hand in hand with that. And actually, speaking of culture, Nick and Joe, you talked a lot about the culture around our SEVs and our processes that surround them. Joe, you were talking about you're a moderator for a main SEV review. It's a blameless culture, but at the same time, we want to make sure that when SEVs happen, that there's accountability to follow up on actions to remediate them and make sure that they don't happen. How do you balance accountability with a blameless culture within our SEV space?
That's a great question. So great timing too. So yeah, accountability and blamelessness can actually go hand in hand. The question is what you focus on. So for example, if you want to hold people accountable in an incident management process, you're not holding them accountable for having the issue. You're also not holding them accountable generally for the fact that the incident response was a scramble, right? That we could improve there, right? Like you have to sort of assume and show up, I think we talked about in our talk, with this assumption that people are doing the best that they can. They don't cause incidents on purpose, right? But the areas where you do want to create accountability are in making sure that the issue doesn't happen again. So showing up with a good incident report, for example, or identifying the correct set of follow-ups. And I think earlier in the Fastly talk, the presenter made a good point, which was trying to make incident response as much about solving a technical puzzle above everything else. And if it becomes sort of a blame game or finger pointing, you've sort of lost. And that's really what we tried to do in main sev review. And it also requires, though, having the moderator be aware of the human dynamics at play and the fact that those sort of things can happen if you're not careful. So you definitely have to watch the discussion, lead with kindness, show empathy for the people who are presenting, and make sure that actually you're not as much telling them what to do as suggesting, having the group come up with suggestions of things that could solve the technical problem of this incident. And then over time, holding people accountable for getting things done that we think will prevent future incidents.
Right, that makes sense. Yeah, it's the technical problems that require people ownership, not people problems, right? Makes sense. You both talked about the process that's involved in filing a SEV, right? On one hand, there's a principle, if it seems SEVy, SEV it. There are some saying similar to that. And so when someone files a SEV, they have to go ahead, open up the tool. Once they open up the tool, there's the investigation and remediation process. But following that, you also have SEV review and you have to prepare the report. It sounds like an expensive process to own and drive. Nick, can you tell us a little bit about how we recognize folks for the work that they put into SEVs and the SEV process?
Yeah, that's a great question, Christian. And you're right that it is a process. And, with all processes, there's a cost and an effort associated with it. But it's an important process for us. When we think about recognition, when I think about recognition, I really think of like two dimensions, right? So like there's sort of like the performance recognition, but then there's also like a cultural recognition, right? So I'll covering each of those like in turn. From the performance side, I think one of the things that really helps with this is building a shared expectation around like what we should be doing in regards to SEVs. So, at least at Meta, effectively all engineers that are responsible for production services are expected to be in an on-call. And as part of being in an on-call, you're expected to identify and raise and help mitigate SEVs. And because that's a shared expectation, it really goes a long way in encouraging people to engage with the process and see the entire process through, because it's something we all share and we can all empathize with. Another angle of the like performance dimension, I think a lot of people, when they think about it, they think about like, well, how am I being recognized, in my review, right? Or at the end of the year when I talk about all the work that I did, how does this work get recognized? And I think one of the really unique things about Meta and makes it a great place for production engineers to work is that not only do we, when we compose our body of work at the end of the year, not only do we look to call out the impact that we've had, but also examples of engineering excellence that we've exhibited, right? And SEVs are a perfect example of that, because it's not just about like, hey, what impact did you land and what impact did you ship, but about the ways that we've achieved that and the ways that ultimately we prevent other incidents from happening. And then, as I mentioned, the second dimension is kind of the cultural dimension. And from a cultural perspective, I think it's really important that, the engineering organization and the engineering leaders care about this and they care about this process. And at Meta, they do. People are excited and they show up at SEV review and they participate in it and they show a lot of care. As a result of that, the people that participate in the SEV process are recognized. They're well regarded, and it's actually, honestly, a great platform for people to both learn and gain visibility. And then, finally, a very obvious thing, I think, to many of us at Meta, but maybe not elsewhere, is there's like an aspect of like swag and prestige that can come with it, right? Within Meta, we have some pretty exclusive swag for folks that have done like an exemplary job in working on incidents or SEVs. And that includes the SEV review process. So the last thing I'll say, though, is recognizing people for SEVs, whether it's the SEV review process or it's the SEVs themselves, it is really important for driving that culture, right? But we do have to be careful not to over-recognize it as well, right? Because we could just as easily fall into a case where people are excited to work on SEVs and they're raising SEVs all the time, right? The main thing we need to do, though, is find ways to prevent the SEVs from happening in the first place, and that's the most valuable thing. And that's why our talk really focused on like the SEV review and the learning side of it, because that's where the real value comes from.
Makes sense. Okay, so we're just about at time, and I'm not seeing any questions from the audience, which I think is okay, since we're at time anyway. But with that, I definitely want to thank all of you for your presentations. Lots of learnings to glean. And I also want to give a big thanks to the audience today for sticking through this event. All of the outage war stories, the panel, the presentations, there's lots to cover. These presentations will be made available as recordings, both on the AtScale website as individual presentations, and the entire event will also be available on the Facebook AtScale page. So feel free to follow up and review anything that you might have missed. But big thanks. This is certainly the first Reliability at Scale event, but not the last. So we'll see you all in the next one. And thanks again for your time.